fifth graders, it's Mrs. Tremblay, and today we're going to look at how to add and subtract fractions with unlike denominators. We've been doing a ton of work with like denominators, and now we're switching it up. So tying back to something you already know, we have 2/5 plus 1/5. So here I have a whole divided into 1, 2, 3, 4, 5 equal pieces, right? So to show 2/5 plus 1/5, I could just shade 2 of these, or I could circle them. And if I want to add 1/5 to that, well, this is another 1/5 right here, so I could shade that or circle it. So 2/5 plus 1/5 we can see is 1, 2, 3 fifths, because it's all divided up into 5 pieces, right? Well, now we have here 1/2 plus 1/3. So this top piece is just to represent, okay, this is a whole. Now this first fraction bar that I have, it's divided into 2 pieces, right? So I can show 1/2 on here, shading it in. If I want to add 1/3 to that, this is not a third, so I can't just do that, but 1/3 would look like this, right? 1, 2, 3 pieces. So if I want to add those together, I can't put this and this together and say I have 2, because 2 what? These pieces aren't the same size, right? So to make them the same size, it'd be easier if I could turn the half into thirds and the thirds into half, right? Well, what we can do is I can take that half and I can divide each unit fraction into the 3 pieces of the third. So here's what I mean. I'm going to cut this into 3 equal pieces. And I'm going to cut this into 3 equal pieces. What I want now is I'd like to change this third into halves. And if you're like, what are you talking about, Mrs. Tremblay? I promise I'm going somewhere with this. Just follow along. So if I want to cut this third in halves, then that would mean I want to take each unit fraction and cut it into 2. Now, I don't know if you notice right now, but I have just created the same size pieces here. So I just broke each whole up into 1, 2, 3, 4, 5, 6 pieces by taking the half and putting it into thirds and thirds and putting it in halves. So what I could do now, since these pieces are all the same size, if I want to take a half plus a third, this was the half, right? And then isn't a third 2 of these pieces? Yes, so I'm going to put it right up here and put it on with this half. So a third is 2 of these pieces. And now I can get my answer because the pieces are the same size. 1, 2, 3, 4, 5 sixths would be my answer. 5 out of 6. So basically what we just did was we got a common denominator. We changed 1/2 into 1, 2, 3 sixths. And we changed 1/3 into 1, 2, 3, 4, 5, 6 to get our 5 sixths. And now instead of drawing pictures for everything, I'm just going to show you how to get a common denominator to just add or subtract. So the good news is you already know how to do it. You did a ton of comparing fractions problems, right? And when you compared fractions, didn't you have to get a common denominator? Yeah, so we use the same exact strategies to get a common denominator when we're adding and subtracting fractions. I'm just hoping this visual model shows you why it needs to happen. Okay, so here I have 3/7 plus 1/5, right? I can't just say it's 4/12 because it's not. I mean, if you tie back to this wasn't 2/5, was it? No, you can't just add your numerators and your denominators. That's not how it works. So if I want to add these together, I need the pieces to be the same size. So what we're going to do is we're going to ask ourselves to create these equivalent fractions. Are our denominators the same? And no, they're not. Can you multiply 5 by something to get 7? No, you can't. So if I was comparing 3/7 with 1/5, wouldn't you multiply the 3/7 by the opposite fractions denominator and the 1/5 by the opposite fractions denominator? Yup, that's what we do. We do the same thing. So now I can go ahead and change these into the equivalent fractions. So 5 times 3 is 15, and 5 times 7 is 35. 1 times 7 is 7, and 5 times 7 is 35. Now the pieces are the same size, just like they were up here. when we can put them together. So all that's left to do is add my numerators. So 15 plus 7 is 22. And I bring over my denominator because that just tells me how big the pieces are. So 22 over 35 would be your answer for the first. All right, for letter B, you might be thinking, Mrs. Trombley, you want us to multiply by 16, 8 times 16? No, I don't. You know what I want you to multiply by? 2. With this one, I see that the denominators aren't the same, but 8 is a factor of 16. I can do 8 times 2 to get 16. So we're just going to multiply this fraction by 2 over 2. 5 times 2 is 10, and 8 times 2 is 16. And this 7/16 doesn't change. It's already a 16. Now that my denominators match, I can add them up. 10 plus 7 is 17. And 16 plus 16 I don't do because this just tells me the piece size. So just bring it over. Please do not add your denominators. Now I have 17/16, which is improper. So let's change this to a mixed number. 16 goes into 17 one time. I can make one group of 16 out of 17. And how many are left over? 1. And the denominator doesn't change. So 1 and 1/16. All right, if you're feeling like, yeah, I think I kind of get this, try C and D on your own and then press play to check your work. All right, with letter C, I see the denominators aren't the same. I can't multiply 4 by something to get 7. So I would multiply 3/4 by 7/7 and 6/7 by 4/4. So once I switch these up and do the multiplication, I have 21/28 plus 24/28. All right, so I see I have a common denominator now. 21 plus 24, well, if I did 20 plus 20, that's 40. And 1 plus 4 is 5, so 45. Leave your 28 alone. This is improper, right? So how many times will 28 go into 45? Well, I think just once, because 28 is pretty close to 30, and 2 30s would make 60, which is more than 45. So I'm going to bring my 1 right there. I know my denominator is 28. Now I have to find the difference between 45 and 28 in order to figure out what's here. You can set this up and borrow and do all that if you want. Sometimes counting up by tens I think is helpful. So if I want to know the difference between 28 and 45, I wish it was 48, right? So 28 plus 10 would be 38. 39, 40, 41, 42, 43, 44, 45. So I can see that it's 17 away. You could also say 28, 38, 48, that was 20, and then count back 3. Or you can straight up do the algorithm 45 minus 28 and cross off your 4 and do your little borrowing. And 15 minus 8 is 7, and 3 minus 2 is 1, and that's how you could get your 17. I don't care how you get your 17, just as long as you get your 17. So 1 and 17/20. All right, for letter D, I notice that the denominators aren't the same, and I also notice that I can multiply 3 by 4 to get 12. So instead of changing up both these fractions, I'm just going to multiply the 2/3 by 4/4, because then I get 8/12, and I'm going to bring down my 5/12, and now my denominators match. So I can add up my numerators. 8 plus 5 is 13. I do not add my denominator, I just bring it over. And 13/12 is improper. 12 goes into 13 one time, and the difference between 12 and 13 is 1. There's a 1 left over out of 12. So 1 and 1/12. All right, now we have some subtraction problems down here, and good news is it's the same exact process. We just need to get a common denominator, but then we're gonna subtract our numerators in the end instead. So these are not the same denominator, and I can't multiply 5 by something to get 6. So I would multiply 5/6 by the opposite fraction's denominator. And I would multiply 2/5 by the opposite fraction's denominator. We get 25/30, because 5 times 5 is 25, minus 2 times 6 is 12/30. So I know my denominator is going to be 30, because that never changes. And now we have to do 25 minus 12. So if you wanted to, you could say to yourself, well, I know 12 plus 13 is 25, right? Or you could count up from 12 to 25. Or you could count back, take 10 away and then take another 2. So 25 minus the 10 would be 15. Minus the 2 would be 13. Or if you wanted to set it up like this, 25 minus 12, 5 minus 2 is 3, 2 minus 1 is 1. Any which way you want to do it, it's 13/30. And there's not a number other than 1 that goes into 13 and 30, so we know that we're done. For letter F, I notice that the denominators aren't the same, but that I can multiply 4 by something to get 8. So I'm just going to change one of these fractions. So that 5/8 isn't changing, but this 1/4 is going to change into 1 times 2 is 2, and 4 times 2 is 8. So 5 minus 2 is 3. We get 3/8. It's already in simplest form. It's not improper. There's not a number that goes into 3 and 8. We are good. All right, letter G, 9/10 minus 3/7. Not the same denominator. I can't multiply 7 by something to get 10. So I'm going to go ahead and multiply 9/10 by 7/7 and 3/7 by 10/10. 7 times 9 is 63, and 7 times 10 is 70. 3 times 10 is 30, and 7 times 10 is 70. So now all that's left to do is subtract. I know my denominator stays the same. And 63 minus 30, so maybe you just go 63, 53, 43, 33. Or maybe you say 63 minus 30, 3 minus 0 is 3, and 6 minus 3 is 3. Doesn't matter to me, as long as you get your 33. I'm a poet and I didn't know it. All right, last one of these. I have 7/10 minus 1/5, and yes, while you could do times 5 over 5 and times 10 over 10, 5 is a factor of 10. So I'm just gonna multiply 1/5 by 2 over 2. Then I'd get 7/10 minus 3/10. And 7 minus 3 is 4, and I keep my denominator the same. Now, 4/10 is fine. That's a fine answer. You can give that to me at this point in 5th grade. Or we can take it one step further and say, you know what? There's a number that divides into 4 and 10. So I can make this simpler. So like I said, 4/10, you can circle it and that would be fine. You could also divide them both by 2. And 4 divided by 2 is 2, and 10 divided by 2 is 5, and give me the simplest form answer of 2/5. I would accept either one at this point. By April, I would expect this, but right now, this is just fine. All right, thank you so much for watching. See you soon.